How's it going, everybody? Welcome back. Jando here as per usual. I was doing some light explaining and I thought I'd shoot a little video to do a little more explanation on what we're doing with the actual background processing at Bricks. I had a little explainer where we were running through and talking through some of the ops and the processes that we're running at Bricks for the actual low-level token translations, and I thought it would be important to bring this back out to you guys and show you a little more what's going on a little deeper in the background. We were diving in deep with a couple of my friends on a call into what we're actually doing at Bricks when it comes to token translations, and I think I got a little bit better way of saying and explaining what's actually going on in the background. So we're currently dealing it, and I'll zoom back out just so you guys can see this. This is actually a visual representation of what's going on in some of these models. It's a very zoomed in and scaled in version. This is some of the older models from GPT, but it kind of conveys the same idea that we're trying to show of what we're actually doing for the manipulation step that allows us to get these better results at Bricks. This is where it gets really fun and interesting for what we can actually do with token optimizations, because we are playing with one of the only untapped spaces when it comes to artificial intelligence in some of these LLMs. We are playing with the actual token embedding layer, as well as some of the positional embedding layers for the actual model optimizations before they start getting fed into the actual LLMs themselves, into the weights. So this is kind of the only space that we really even had to play with, and this is where we started when we started doing some of the token optimizations and some of the deeper ops actually at Bricks. So one really cool way to look at this, and I'll pull in a piece of text just so we can see something along the lines and up on something. At BRX, when we're dealing with token optimizations, we are going a little deeper into what is actually possible outside of the realms of some of the models and some of the libraries like LLM Lingua. I was doing a little deep dive into this. They have a custom model that they're using for reclassification on this. We found some better performance using just the default generic models from some OpenAI models and some of these other ones in the same sense, using some of the engineering from the actual prompt optimization step. However, we might even be able to pull out some better compression using some of these. But this is only one step in the bigger process of what we're actually doing at Bricks, which is why this is super important. So I just chucked in a piece of text here, and I'll run a simple compression and a simple optimization on this one so you guys can get a little bit better of a picture of what's going on. So we can use the models themselves as a self-optimizer for semantic compression in a way where we can find, detect, and then reallocate tokens that are potentially not very useful for the context of the LM. In doing so, we let ourselves pick out the actual tokens and then recreate some tokens in this instance of words and values that could be more important to the LLM. But in doing so, we can look at the actual changes, and in this case, the downstream changes on the actual engineering to pick out tokens that are potentially insemantically useful and insemantically valuable for the LLM. In doing this step, we can identify and classify the actual tokens that we want to do the translation on at the core. This is the coolest part, and I think the initial sub-step that we're allowing with this kind of structure, where since we have this auto-tokenization process that allows us to optimize for single tokens and individual tokens, we can then chunk out and strip out some of the actual insemantically important pieces of context that are being fed into the actual token embedding layer to do weird manipulation steps before we actually even hit the matrix multiplication for the actual model weights themselves. This gets a little deeper when it comes to some of the normalizations and some of the other steps, so I cannot really explain to you why what we're doing is working, but what I do know is we are poking at something exponentially strong inside of this token optimization, which is also, I feel like, going to lead down to a bunch of weird instances when it comes to even other positional embedding attacks, as well as some positional embedding optimizations that can also be made. I was discussing with a couple of my friends on how even some of the Google models I think are going to be very susceptible to position-based attacks in the future, just due to the fact that what Google is doing for these infinite transformers and these large, massive KV states that they're pushing out for these LLMs. Now, this gets a little deeper, but I think at the core, I'll kind of dive back into the thought process and how we even got to this point. When we were originally talking, I was explaining out some of the initial concepts when it comes to artificial intelligence, and one that I really enjoyed, and I've been reading into these a lot, was LSMs, so liquid state machines. That same idea of just this big jarbled mess of weights that has the ability to do a really specific piece of math on a really specific input to mimic an output that you're looking for. And this is the idea of training. When you're training the weights, you're training an actual mathematical operation to be performed on a model. So when we start manipulating the actual token embedding space, we're pushing these models into places they've never really been. And in doing so, we are ripping out these performance increases that otherwise would just be left on the table. Currently, we're playing at the token embedding space, but I think there's going to be deeper transforms at some point that we can actually play it at Bricks when we're making our own custom models that have weird parameters. But this is kind of diving into the future, and even my future predictions. If you made an entire model that had an actual normalized and balanced tokenizer for the embedding layer, I think you get a much better output. Before you actually get down to the softmax that then recompresses to the actual end effector or the token that you're pulling back out, I think there's a lot of like little tiny components and little tiny pieces that people haven't even looked at optimizing and tuning. And this is kind of what we let ourselves do and what we set ourselves up with the engine for at Bricks. But this is kind of I guess, a brief intro and like a poke into this. I was even looking through. This is actually kind of some fun statistics too. If you were following along on Twitter, I was able to take out and take over this prompt engineering competition. I was using the initial versions of the GPT-2 tokenizers, and I'll pull out one of these. I just had this one greatest in to actually give me pre-processing steps of token locations to allow me to do better transforms. So when I was originally figuring out how to pre-optimize and how to pre-optimize or optimize these, if you look down and scroll through some of the past results, you'll see my chain of thought on how I was getting into really digging this back out and figuring out what is the best way to make these actual translations before I even started just poking. I ended up finding this weird one with double space greatest, which ended up just killing everything. That's a little bit of a conventional heuristic that I found over the map by just pushing this out. But in doing so, I use the actual tokens itself to lead me down the path to find that actual, I guess, better token optimization that we were running on. But I guess that's a tiny little brief one. Going into some interesting stats, I think it's something like I had a control input around 7. I think it's 9, if it's just not even in this category. But the cool part about this is a fun little statistic. I am in theory outperforming, when it comes to prompt engineering, 99.47% of people. So it's kind of cool. This is not a very good statistic for the ones that are coming in, but I am able to do this, which I think is actually kind of impressive for the amount of tokens that I'm spending to figure these things out. Other people are getting desired output reached, but at a much lower percentage from what they are trying to do. I mean, this might not be the best chart to even show or display this, but we were looking out into the actual frequency, and I was looking at some of the other competitors in the event. I was able to reach the same performance as this person here with about half the actual tries into their engine, for instance. So it's a very interesting concept space that I think I have a very weird perspective on that's allowing me to do very complicated things inside these LLMs. But yeah, that's about it. This is a weird late night one. I'll show you guys another little thing, which is kind of cool. I just did full swagger generation. These will probably be public bricks near future. I just made a couple bricks to do this other one. We were working on some of the documentation at Bricks, but full doc generation with a TypeScript recompiler. This one was kind of cool. We were able to even do an AST tree parsing. And the best part about all this is I did this all in one night because we have the best thing to ever exist in humanity, which is AI, and we have our own tools for coding as well. So I was able to have my own agentic process at Bricks generate me code that allowed me to do a very, very complicated transform onto an actual API spec that we can spit back out for something practical. This is a small test case, and I was able to do this one night, which is hard to believe for a lot of people, but it's the truth. But yeah, so we're going to keep building. We're going to keep making better stuff at Bricks. I hope you guys enjoyed. As always, make sure you follow along for the ride. This is going to be a fun one. We are getting ready for our raise for our seed round. So I hope this makes it to you in the best. But that's about it. I hope you guys enjoyed, and I can go a bunch deeper on this in another day. It's actually 2:14 if you can't see, so I need to go to sleep. But that's about it. I hope you guys enjoyed, and as always, I will see you guys next time. Bye, guys.